I'm Sarita and I'm a senior sales engineer with Snowflake. Snowflake is a SaaS product which is available on 3 cloud platforms, cloud service providers, which are AWS, Azure, and Google. And this actually makes it one of the solutions which is cloud agnostic, cross-cloud, and also multi-cloud, where most of our industry is working on. So with that introduction, I would like to go ahead and take us through the next slides. So what does it mean when I say that this has been this is the future of AI, where we have got companies who are scaling into AI and getting 3x results. Forecasting of your data, your predictive analysis. We could only do prescriptive analysis for past some of our lifetimes, where we used to see a problem, get the problem solved, and then we used to find out, okay, what could be done better. But now we are at a place where we have a challenge, or we even do not have a challenge, but we can actually predict that this would be the one which is going to come in. There are various models which are available right now as we speak. Many of the students who belong to machine learning or data science backgrounds would already know about the theoretical implementations. Even statistics or mathematics students, linear regressions, polynomial regressions, and all that. I'm not going to talk about them today. I'm just trying to give you a vision about what is happening in the space of AI and ML, yeah, and what are the building blocks towards the same. So with those building blocks which we have built on analyzing the data, and here we are not talking about terabytes of data. We are right now talking about petabytes, in fact zettabytes of data. There is a statistics which says, and it is by statistica.com, that we would be actually getting in 168 zettabytes of data by 2025. Yeah, so that is the scale that we are working on, and with this much of data which is going to feed into our systems, you could always understand that whatever analysis we are doing, it just cannot be the analytics part of it, where I run reports, where I just run select queries on existing data sets. No, we have to break the barriers and we have to walk a path where we can do much more with the data, whether it is monetization, whether it is analysis which is predictive in nature, or there are multiple other tools which could help you in getting much more information out of your data. So make your data work is the short form that I wanted to tell you. Okay, now we talked about how the ML models are, how do we work and everything. But then what is the gap here? This is not something which is new. As I told you, first papers of AI or data science were actually written in Stanford University about 50-60 years back. There are people who are like Jan LeCun or even Andrew Ng, who are a part of this industry and who have been working on this for the past 30-40 years, their entire lifetime, and they are really great academicians. But then why do we hear these things right now? The reason is this, that you are seeing right now in front of you. This is, we already had the data, we already had the training and evaluation, we already had the feature engineering part. Don't take up these keywords. Feature engineering is something like combination of 2 columns and then generating aggregates or generating some kind of meaning out of those data which is existing in them. Yeah, so just don't get bowled out by any of the terminologies here. So usually the data is divided into 2 parts. One is the training and second is the model building. So you actually train the data with the training data set, which is 20% of it, and the rest 80% of it you actually implement on the model. So we had this and we had the testing environments available, but we did not have enough tools. We did not have teams which could talk to each other in the language that they wanted. I could code in Java. My teammate could be an expert on R. There was another person who was my vendor who was an expert in Python. And my data still was there but not was used, because all 3 of them are working on different technologies. But what if I tell you that Snowflake today, with something which is Snowpark, you could actually run your code on ANSYS SQL, Python, Java, JavaScript, and Scala. So this is the complexity which we have solved. So siloed data and teams and technical barriers have been broken down. Next is processing complexity. The data, so we are not talking here about small amounts of data. We need the architecture behind it. We need the power behind it to process all of that data. With cloud, we are getting a very, very high amount of CPU, memory, warehouse, compute, whatever you call it. You have the option of scaling out, right? You have got the option of scaling up, and thus it solves the problem of how do I execute the query on this huge amount of data that I have residing on my systems. So this particular problem is the problem which has actually made a lot of SaaS solutions very, very successful, which is processing in complexity. The third is the broken data foundation. So you have your own data, but all of these use cases which you are talking about, where you need, let us say, geospatial data to find out how much, so manufacturing is solving this problem. Where is my truck lying right now? Which is the nearest service point? Telecom is solving the problem. How are the people going to roaming? And if yes, do they need any kind of insurance? So see the amount of complexity that you are having. It is telecom plus insurance plus manufacturing. So no one is siloed here. You need multiple amounts of data. You need the geospatial data, IP code data together. But this is something which is not available. But again, Snowflake solves this problem with the help of something which we call as marketplace, where you can get the data and also your applications. So I told you the problem and the solutions which you are seeing on this particular screen, which is saying that we have a natively integrated ecosystem. I told you about Snowpark, which solves your technical challenges. I told you about Marketplace, which solves your data retrieval challenges, the first party, second party, third party data retrieval challenges. We talked about multi-language and elastic engine. Your CPU or your compute power is scale up and scale out model, which is the elastic nature. You also have multi-language support, and then the unified data access. So multiple sources of data coming in together, and you can process it at one shot. Yeah, this is what we are talking about here. And along with this, we also offer some of the things like Streamlit, which makes it very, very easy for us to even report your data in graphical fashion. Yeah, so this is what it would look like. We have got Snowpark APIs and native connectors. So Snowpark API helps us in pushing down your code from multiple technologies. There are multiple connectors. Either it is Jupyter notebooks, Hex notebooks, your VS Code, or it is ODBC, JDBC connectors, or it is APIs through which you can connect with the code. You have all sorts of connectors which are available. A whole plethora of partners who are with us. Yeah. So next is with Python or even with Java, you could use UDFs, UDTFs, which are user-defined functions and user-defined table functions, stored procedures, and multiple other such constructs when you are coding on any of these languages. Yep. Next is the availability, where you have XGBoost, TensorFlow, NumPy, extensively used around. And the last one is Snowflake gives you an architecture where you can actually go ahead with any of the design patterns of your data. Data warehousing, data lake, data mesh, data fabric. Which one do you want? All of these design patterns on data which are growing in popularity or in implementation are implementable on the data which is there on this particular ecosystem. How does Snowpark work, right? So I told you about Snowpark being multi-language and helping you out with the same. So what does it do? It does this, that once you have written, so usually all these languages which I talked to you about, which is Python or Java, or in fact Spark with Scala or Python, they are transforming the data, which is very, very large amounts of data, and then gaining insights out of them. How do they do it? The basic element is something which is called as data frames. So what are data frames? When you are writing your code, there is a lazy evaluation of your data, and those constructs which you have written are actually being thrown, compiled, and then being executed. So this similar kind of fashion has been built on top of Snowflake itself, and it is not something which we bought or we acquired. This is something which is built on the architecture of Snowflake, which we called as Snowpark, independently built for on the architecture for the utilization and performance benefits. Yeah. So you get the data frame, and then what you do is we push it down. That is, we would take your code, convert it either into a SQL query or a Python bytecode. Just imagine that it is the Python data which is coming in into the system, then the Python bytecode, and then this Python, either the SQL query or the Python bytecode, or in case it is Java, the Java bytecode, that is something which is analyzed and processed on top of your system. Also, let us say it is Python ecosystem that we are trying to tap. Python has got a lot of functions, and I mean lot of packages. So all of those packages, we have built a system with Anaconda, which we call as environment, and once that environment has been created, so with Anaconda, what we have done is we have built a safe channel. That is, only the certified packages will be available for you to create a non-dependency kind of a platform. So if any one of you has worked on Python, you know what is dependency hell. You have one package, you call the other, import package, you call the other package, but then it doesn't work, saying the version is incorrect, or even if it has not said that error, but then your code doesn't work. So this is where this comes into picture. Get only the safe certified packages from Anaconda, build a safe environment so that your code on Snowflake can work there independently. Yeah. And again, Streamlit, which is another part of the story, where you could get in your entire Python code into the system and then run the same to generate reports, is the next section that I would like to touch upon. So now I told you what was the problem, how do we solve it. Now showing the bigger picture or the larger picture, what would be the end-to-end machine learning when we are using Snowpark. Snowpark is an API where you can use multi-languages, just reiterating so that we are on the same page. Now the data has been acquired, right? So you have got your first party data, which is your data. You got your second party data, which is your customer data, partner data, data which is directly provided to you, or even IoT data or any other data. The third party data is your geospatial data or any other data, currency conversion data, or any other information that you wanted to have. So all these things together you acquired. Next, you decided upon your training data set. As I told you, in machine learning, you have got a training data set and a modeling data set, 20 and 80% usually distributed. Then what you do is you would write your procedures. You could write it as UDFs, UDTFs of Java or Python, or you could write it as on Jupyter notebooks of Python, or you could also write SQL stored procedures on top of Snowflake itself. So you wrote that, and then those particular stored procs which you have used to fit and train your data moves into a saved model object, which we will call as stage, and then this model is moved as a UDF, which is a user defined function, which then gets the inference data set. Yeah, the inference data set, which would be like, okay, I have got the data which was developed, I am trying to make use, or I am trying to make sense of it. So that is where the inference part of the model building comes into picture, and then you use your scalable data resources and your warehouses, CPU, monitor, memory and everything, and get the data moving in for your data predictions. So you have built a complete model cycle on top of Snowflake, which is the end-to-end machine learning, where you have used multi-languages and you have used multiple sources of data. It could be structured, semi-structured or unstructured data, which can flow through into Snowflake. So, and the processing is also pretty simpler here. So this is the end-to-end machine learning cycle that you can follow on top of Snowflake. Now, how do you build it faster would be a question. Or how can we build apps on top of Snowflake or the data cloud? Then what it would mean is that with the programmability which we have brought in on top of data, we are ensuring three things. Once your data comes in, the data never moves out. So your data is absolutely secure and governed. One of the most important aspects. You do not want to take your data and play around with it. This is a very, very bad recommendation if anyone is giving you that. Yeah, data is the most important aspect. We have got a lot of PII, which is personal information. We have got a lot of people out there who want to take handle of this data, and then you never know what could happen with your company after that. I have a bad incident at the back of my mind, but I don't want to talk about it. 6-figure ransom amount with Western Digital just 5 days back is on the news, and they have taken the data. So data is that important, and it should not be something which you are moving around. So what we are saying is, once you get your data in, it is secured, governed, use it with it, and use any technology, any platform, any kind of scalability that you want. Next is, can you build applications on top of your data? Why not? Why not was the question that we asked. So yes, this is the answer. We can build customized applications, managed applications, and even native applications. You got all the data, you got the programming languages, now you build applications on top of it, and you can also put it on the marketplace to monetize the data. You could also support the dynamic demand and deliver better experiences, because you now understand what is the application that you have built on top of it. I have a demo for us today, just to show the technical part of things. So I told you that we can work on Python with Snowflake. So there might be some questions around it. I could have also used a Java instance, but Python should be good for us because that is one of the languages which is used across. So this is a simple Jupyter notebook. I have already, just because of the network scenario and the time that we had, I just ran this Python notebook just before we entered into the room. So what does this do is connect with the environment. I have given my credentials. I have just checked what is the credential of it. If anyone here knows Python, you will be able to see that it is using the same session.table and df.show to show you the results of a table set, and then also show the tables of a campaign spend. So I am getting the marketing data and the spending data together to actually predict what would be the seasonality of the ticket trend, okay, in very simple terms. Total spend for channel per month, nothing but this is how you are actually using a group by on top of a select column, and you are joining a query across two tables which are campaign spend and market spend. Next is we are taking up all the data which we have got in the data frame and then selecting for specific columns out here, and the output of those columns has been listed here. And then what we have done is we have calculated the monthly revenue, and that is actually displayed on the screen. Next is we have done the calculation of the model building. I'll just quickly go into the model building. So this is what I was telling about, that here is where I have used the scikit-learn, and I have got it on from my Snowpark environment which we have created, and this sklearn is actually using the entire data set to train my data. So you could see the preprocessor, the pipeline steps, the preprocessor and the classification of the data here, where the parameters are being passed and then the revenue is being analyzed. The model has been built on the grid search CV pipeline and the params which have been generated. the model has been fitted with 2 parameters of training, and then the join has been, the join is actually getting processed so that you could get the data. I do not want you to actually go deep into it and understand everything. That is not the intention, but the intention is just to show you the power that we could actually do when can code on the same data which you have on your databases on Python, Java and multiple other languages. Yeah. So this is where, so how does Snowflake look like? I have a console here just for us to understand. So it just looks like this. If you have used SQL Developer or Toad before, anyone, if you are that ancient as me, then you would see this. So there are worksheets. Here also you could actually see that all the text that I have written is either in SQL or it could now also be on Python. So this would bring you a lot of flexibility and ease of use. And the data which I was telling you that I could get it from Marketplace, this is the place where you could get the data, and some of the data is absolutely free. Yeah. So this was about how we could build AI and ML cycles with flexibility of data and also have it so that we can use it for, you know, I could not get my Streamlit application up, but I would like to show that to you as just a simple video recording, where this is how you could build an application on top of Snowflake with the help of Streamlit Python coding, where you would take just 300-400 lines of code and condense it to 30, and you could get these kinds of applications up and running. Yeah, so get your data in, process the data for normal usages, also use it for machine learning and model building, and then display your data in very, very beautiful graphical interfaces with the help of Streamlit. With this, I would like to conclude my session.